Hi, welcome to Physics 2.1 Vertical Motion Problems. Unit 2 is all about throwing objects up, down, sideways, everywhere. These are your variables to consider. The initial velocity is v naught, right? The vertical velocity the object is thrown, launched, etc. The final velocity is v. The vertical velocity, again, of the object at the apex of its trajectory, its highest point. This should be 0. Think about when you throw a ball up, when it's switching from going up to going down, that teeny tiny fraction, momentary pause. T is time, and this is the time up to reach its apex. And the acceleration now we have to consider direction is always down, and it is always negative 9.8 meters per second, or meters per second squared. Facts to know. Up is positive, down is negative. Acceleration of all objects in the air is gravity, which is 9.8 meters per second, down. If an object is going up in the air, the acceleration is still negative, but the velocity is positive. If the object is going down in the air, the acceleration and the velocity are both negative. These are 3 diagrams that you're actually going to get a different version of later. Notice that the first diagram on the left is falling objects, that we did that in 1.4. Then in the middle diagram, we're throwing an object up from the ground. That's what we're going to do today. And then it's going to come directly back to you. And then in 2.2, we're going to throw objects up and away from us, again from ground level and from different heights and so on and so forth. So this is the diagram that you're going to get for falling objects. This was 1.4. Since falling objects only have one direction, it didn't matter where we put 0. It didn't matter that acceleration was down. Everything worked just hunky-dory because we were finding speed, not necessarily velocity, because velocity was going to be negative as well. When we throw objects up from the ground, notice in this diagram, everything is labeled. Ground is 0, where the velocity, it has a velocity greater than 0. Your delta y is your height, okay? The velocity at the top is 0. So when we throw objects up from ground level, we turn the tables. Acceleration is negative, y naught is 0 at the bottom of the path. So right now, pause, get your formula sheet out, and add the following 2 slides. So here are your equations again. Kinematic 2 is now y is equal to y naught plus v naught t plus 1/2 at squared. Don't forget the squared. Kinematic 1, v is equal to v naught plus at. And kinematic 3, v squared is equal to v naught squared plus 2a delta y, meaning the change in the height. Where y is the vertical height in meters, y naught is the initial height, which should be 0. A is the vertical acceleration, in which is 9.8 meters per second, which is negative all the time. T is time in seconds. V naught is the initial velocity in meters per second. And V is the final velocity, again, in meters per second. Delta y is the change in y, which is the displacement height. So, in kinematic 2, we use kinematic 2 to find the height of our object. How high is it going to go? In kinematic 1, we're going to use that to find time or velocity. And kinematic 3, we're going to use to find velocity or height. So here's example 1. An object is thrown into the air from the ground with a velocity of 3 meters per second. How long does it take to reach its highest point? Well, again, use your equation to find time. V is equal to V naught plus AT. So V naught is 3, acceleration is negative 9.8. Calculating that, you get a time of 0.306 seconds. So then how high does it go? Using kinematic 2, plugging in all the values that you know, notice that gravity is again a negative 9.8 and it has to be a negative now. Okay, it does matter. Plugging all of that in, we get a height of 0.459 meter, about half a meter. All right, this is what you're going to be doing in class today, throwing objects up from the ground, having them come back to you. Good luck.